What is pinch off?
Saturation.
Saturation. Why saturation? Pinch off? What happened during pinch off? Ingat lagi tak pinch off tu apa? What happened during the pinch off? The channel become a triangle, right? Then the current will be higher or the current will become constant. Now this is N type. Pinch off dia become triangle.
Become constant bila.
Yes, so the current become constant. Okay. So when you want to solve, this is the first example of your DC analysis. Awak semua dah tengok kan video tu? I hope so. So if you see, this is the first example. If you see the examples, it will always say confirm any assumption you make during analysis. So this is the common statement inside your okay, for your information, your final, how many questions inside your final? You have 4 questions. You can see my screen, right? Can you see my screen?
Boleh, madam.
Saya tulis ni awak nampak tak? Oh, nampak kan? Nampak ke tak nampak?
Nampak, madam.
Nampak Okay. So you have 4 questions. Final ada 4 soalan. Whatever cover inside your midterm will not be covered inside your final. Okay. So 2 questions will be BJT. Another 2 questions will be FAT. Okay, the one that we already covered is the BJT. So first is the DC analysis. Second question will be AC. Number 3 question is FAT DC and then FAT AC. So now we are going to solve, each question will be 50 marks. Total of your final will be 60%. Okay, 60%. So now we are in question number 3. So the all example that I give to you here is all the past year questions. So you are going to expect your final question will be some sort like this question. Dia macam tak lari jauh pun, maybe dia akan tambah some diode ke, some extra there. But if you can solve all these question, means you actually can score question number 3. But when you look at the question, they always akan cakap macam ni, confirm any assumption. So why it say confirm here? What come in your mind when it say confirm? Confirm means what? In your saturation. Siapa jawab tadi? Ayu Who's answering just now?
Yes, madam.
Okay. What does mean by confirm, Ayu?
Means in saturation or not.
In saturation or not. Kenapa kita nak ada dua in saturation or not? What happened actually? Is there the same equation or different equation for saturation and triode? Saturation and triode different, right?
Equation.
Because they are having different equation. If you look at your BJT, you don't have any confirmation. Semua sama je equation, either you are active cut off or active cut off or saturation. But inside your MOSFET, you have different equation. Okay, what is the equation at your saturation? Can you open your notes and give me the equation? How many current inside your MOSFET? How many current inside your MOSFET?
One current.
Why one current are you? Why we don't have IG? Why no current at the gate?
Because there is insulator.
Yes, because there is insulator at the gate. There is no current will flow, but what will flow at the gate? Apa yang berlaku kat gate ni? What happened at the gate? MOSFET. The name is FET, Field Effect Transistor. When I draw the direction like this, what is actually happened at the gate here? Electric field. Electric field. So there is only electric field, there is no gate. So this is NMOS or PMOS? In BJT, you have 2 type. What is the type of BJT? Arrow keluar, NPN ke PNP?
NPN.
NPN. Arrow ke dalam, PNP. In your syllabus, PNP tak cover, it's only NPN. Same with here, we have arrow outside, NMOS or PMOS? Yang ni. NMOS. Okay, NMOS. So this is N. What does mean by NMOS? Your substrate is N type. Your substrate is P type. Here is N or P? NMOS. Dekat source dengan drain ni is N. Okay. What about PMOS? PMOS arrow is going inside. Then what will be here? Here will become P and here will become N. So there is a difference. So PMOS will not be covered inside the syllabus. We are going to focus on NMOS and NMOS. Okay, so go back to here. So you need to confirm. Since you need to confirm, so you have two equations. So now, how are you going to start? What is the equation for saturation? Can you open your notes and give me the equation? Equation for saturation. ID equal to
Kn
Kn
VGS minus VTN
VGS minus VTN
square.
squared. Okay, thank you, Ifa. Kn VGS minus VTN squared. Triad is a long equation, so you can refer to the notes. Okay, so now let's see this circuit. If you recall your Bjt, you have almost the same circuit. What is this function of this circuit? I think you do your lab also with this one. What is the name of this circuit? Ini Bjt, this one is NMOS. Can you see the similarities between these two? Then what is the function of this circuit previously? Apa yang awak cuba buat kat circuit ni sebenarnya? What is the name?
Thevenin equivalent circuit.
Yes, that is the process. We call this one, we are going to change to Thevenin. Why you need to change to Thevenin? What is the purpose actually? Your final aim is you want to find what from this circuit? Final aim. After VTH, your final aim. You want to find I what?
VGS.
V what?
VGS.
Yes, are you? I? V, no, Bjt.
ID.
IC ke IB ke IE? IB ke IC ke IE?
IC.
IC and VC? And VCE,
VCE.
right? VCE. Process to go through this one, what we call the whole process of this one? Apa yang kita tengah cari ni? Yes, the keyword is biasing. Biasing. What is biasing, Farizi?
Finding Q point for
Why?
amplification.
Okay. Why you need to find that Q point? What is the
Actually,
purpose?
region, active region.
Yes, to find either it is inactive, cut off, or saturation, right? To find, okay, thank you Farizi. To find its active, cut off, or saturation. So, why you need to have this? Why you need to really know whether it is inactive, cut off, or saturation? Kenapa susah-susah nak tahu region ni? Najmi, kenapa susah awak kena belajar nak tahu region ni? What is the function of transistor? Yes, because you have two functions, right? One is to amplify, another one is to become a switch. So now your focus is to amplify. Okay, inside your Bjt, to amplify, you need to go to which region? Active, saturation, or cut off?
Active.
Active. How you know that this is active? The process is called biasing. Yes, correct. Biasing, that's why you need to find IC and VCE. So if you understand the whole story here, this is like a story of electronic. The same will apply with the NMOS. So let's make a story of your NMOS. Again, you want to make it as an amplifier, but you don't want to use Bjt, you want to use NMOS. So you need to bias. The process is called biasing. Bias in which region? Active ke, saturation ke, cut off?
Saturation.
Yes, you need to bias in saturation. You need to bias in saturation. So how you're going to bias? That's why I say the process is called. You need to change it to become Thevenin and RTH. But now here, you are not going to find ICVCE. What you need to find here? What is the Q point here? Q point kat sini apa? Yes, ID, VDS. Okay, so let's go back to the question. That's why they say confirm any assumption you make during analysis. Why this is so important? inside your MOSFET because you have different equation. Saturation, different equation. Triad, different equation. Why this so much matters? Because you want to go to the amplification. You need to make sure in saturation. So now you need to confirm now in saturation or in triad. Which region that you need to start usually when you
Saturation.
want to. Yes, kenapa saturation? What do you think? Kenapa tak pilih triad? Which
Constant.
equation?
Constant
Yes,
current.
constant current, correct. There is another reason. Which equation that lagi simplify, lagi senang? Triad ke saturation equation?
Saturation.
Saturation kan. So again, because the final aim, like Faizi said just now, you want the current to become constant. And another reason is because triad ni dia punya equation is very long. So you're going to have a complex calculation. So usually we always start with saturation. Okay. So that is the story. That's why I said if you understand Bjt question 1 and 2, the understanding will follow to question 3 and 4. It will happen the same story happen, just the calculation will be a bit different. Okay, so let's go through the calculation now. Okay, now you see this one is biasing, right? Circuit or biasing. So now you need to change to VTH. Okay, now let's change to VTH and RTH. And then here instead of Bjt you have NMOS, and then you have RS, and then you have RD, VDD. Okay, can I have one volunteer to have the equation? Which one you're going to start? DS loop or GS loop? Nak start mana? We have two here. Here is DS or GS?
GF.
DS. Sini GS. Okay, let's see what is the number given in the question. Saya dah teranjak Oh, salah soalan. Saya buat soalan satu. Okay, let's go to the first question first. Tadi saya teranjak. Okay, now let's see the question. Key hint number 1. The question say design. So you see this keyword repeatedly inside electronic. What does that mean by the word design? Means you need to find what? Yes, you need to find the unknown R. So when you want to find the unknown R, it always gives you the final value. So what is the final value here? Is the Q point, IV, ID and VDS. So you are given the rest. What is threshold voltage? What can you understand from the word VTN, threshold? What does it mean by threshold voltage? Is that it? Threshold apa threshold?
Minimum voltage to turn on the MOSFET.
Yes, minimum voltage to turn on the MOSFET. Okay, so when you're given the threshold, okay, now how are you going to start? Are you going to start with a GS loop or DS loop?
GS.
GS.
Okay, let's start with GS. Can I have one volunteer for the equation? Any volunteers?
Negative VTH.
Ifah. Okay, thank you, Ifah. Negative VTH, but this is not, we don't have any VTH here. Dia ada RG dengan RS je. Do we need to transfer this to VTH, Ifah? Kena ke tak? What does mean by VTH? VTH means when you have like the circuit just now. Mana circuit tadi? Saya counting tu. Dah hilang dah. Ni. When you have R1, R2, this is what we call voltage divider biasing, right? But if you look at the first circuit, do you need to transfer this one to VTH? Nak kena jadi VTH ke tak? Ifah. Ke boleh directly buat loop? What do you think? Directly loop or you need to transfer to VTH?
Directly.
Directly, okay. So can I have one volunteer to have a GS loop? Nazif, boleh Nazif? Try. Boleh? Okay. Start from here.
RG ID
IG. Okay.
0 ID.
RGID. But di sekarang
0
0. Okay. Plus
VGE
what is the voltage across here?
plus VGE.
VG. Remember VG apa?
Yes.
Yes,
Oh.
VGS, right? Kalau BJT, you have VBE, right? But inside your MOSFET, you have VGS. Okay. Lepas tu?
RSID.
RSID. Okay. Last one?
Minus 8
Yes,
to 0.
minus 8 equal to 0. Correct. Thank you, Nazif. Okay. So VGS plus RSID minus 8 equal to 0. Okay, now do you have the value of VGS? Is the VGS given? Yes or no? Is the VGS given? No, right? Okay, no. RS, the one that we need to find again, no. ID is given. And we can't solve this equation. Then we need to have another equation at the DS loop. So can I have another one volunteer? Siapa nak volunteer? Dah tinggal 4 kelas je ni. Suara siapa saya tak pernah dengar. Taufik boleh Taufik? If you keep quiet, I don't know whether you are there or now or no.
Try madam.
Ini siapa? Amar. Okay, Amar. Good. Thank you for volunteering. Okay, Amar. Start DS loop daripada atas.
Negatif 8.
Negatif 8 plus
RDID.
RDID. Awak kat malah ke?
Madam.
Oh.
Saya nak slow down jam.
Meriah betul bilik. RDID.
Betul.
Okay, plus
Lepas tu plus dengan VDS.
VDS
Lepas
plus
tu plus dengan RSID.
okay, betul. Lepas tu
Tu tolak 8.
tolak 8 equal to
0.
0. Okay. Thank you, Amma. Is it correct, class? Najmi, betul tak Najmi?
Betul insyaAllah. Betul.
Betul lah, insyaAllah. Ini lah yang benar. Okay, RD is not given. RD is not given, right? ID also is not given. VDS, yes, 3.5. RS is not given. You don't know also ID, minus 8. Still, you can't solve it. So, what you need to do actually? You still can't solve the both equation directly.
ID tu 0.9.
ID dah bagi. Okay, ni 0.6. Ni 0.6. Okay, yang tadi ni 0.6. How many unknown you have now? RD, RS, VGS. 3 unknown kan? Right. So, still can you solve it?
Guna equation separation.
Yes. So this is where the different thing between your BJT. Okay. So you need to, it says here, it's not saying confirm. It says already here, MOSFET is operating in the saturation region. So this is a difference between your MOSFET. So what happened here, you need to use the saturation. Before you use that equation, what you need to write actually? Before you can use
Assume.
assume. Yes. Don't left this word. Assume saturation. because after that you need to confirm. Okay, so assume saturation ID equal Kn VGS minus Btn squared. So you are given your ID is 0.6 milliampere. Kn is the conduction parameter is 0.58 milli. You don't know your VGS, but you know your VTN is 1.7 squared. So can you calculate for a while? What is the value of your VGS? Minus 8 RDI. Amar macam buka lagu.
Oh, bukan saya madam. Sekejap.
Oh, jiran.
Jiran.
Kita macam lagu klasik. Sampai RDID. What is the value of VGS? Class?
Unknown.
Unknown? Berapa?
Saya dapat 0.6829.
Sekejap, saya tengok jawapannya. Tak.
Bukan.
Saya dapat 2.71. Cuba kira balik.
7.2.
Yes, 2.71. I got 2.7. You got 2.72. Boleh lah ralat. 2.71. Check back. You move this one down. Then you square root. Square root 0.6 milli VGS minus 1.7. So can everybody get the same answer?
2.717 madam.
Yes, betul. 2.72 lah kan? Saya punya salah. 2.72. Okay. So, okay. Now you already got your VGS. So now it's become okay now. Means now you already know this one, right? 2.71. You know your ID. Then you can find your RS. So this one you calculate later. Okay. And this one also can be solved and then you can get your RD. The answer is here. Okay. But is it done? Ni dah kira dapat full mark tak? Ke ada something left? What do you think? Done or not? Kena? Apa yang tertinggal,
Kena.
Farizi?
Yang Pak assume tadi kena confirmkan.
Yes, betul. So don't left this one. Mana marker saya? This one just now assume, right? Assume. So if you stop like this, you will you will not get full marks. Once you always use assume, you always need to confirm. Don't forget this step. Okay, how you are going to confirm? Macam nak confirm?
VGS minus VTN.
VGS minus VTN ni apa benda sebenarnya? Equal to what?
Saturation.
VDS saturation. VTS saturation, right? So, okay, let me explain again. How you can see this one, you always go back to the characteristic, the IV. This is ID, this is VDS. So there is always one boundary point, dot here. This is what we call VDS saturation. What is VDS saturation? VGS minus VTN. So, in order for us to make sure which one is saturation, number 1 or number 2? Number one, right? So when you want what you want now is saturation, right? Saturation. So the condition here, you need to find the value of your VDS, which is here is already given 3.5. You need to be greater or less, more or less than VDS set. Then the boundary more. So you need to prove this condition. Now your first step, you need to know what is your VDS set. Okay, just now I think Ifah or Hani say VDS set is VGS minus VTN. So what is VGS just now? 2.7. 2 minus VTN is 1.7. So you can get here around 1 point, how much? 2.72 minus 1.7, 1.02 volt. Okay. Okay, now here is the condition. VDS, what is the value of your VDS? The Q point here, 3.5. What is the value of VDS at the boundary point? Yeah, this is what we call the boundary point. The boundary point here is the VDS saturation. The boundary point here is how much? 1.02. So now this is greater or less? Greater, right? Greater. So is your assumption confirmed now? Is it in saturation or in triad? This condition.
Saturation.
Is it?
In saturation.
Yes, so it's confirmed. We need to write this word. Confirm saturation. Confirm saturation. So don't ever use this equation without writing this word. Assume that there is some marks here. Because you can't use this equation if you don't assume it is saturation. Okay? So once you assume saturation, you need to confirm how you are going to confirm. Find your VDS saturation first and check whether it is much more greater. Yes, it is confirmed saturation, means the value that you get here is correct. The value that you get here is in the saturation mode. Okay, class? Faham tak? Ada soalan tak? Do you have any question for this question? Is it clear?
Clear, madam.
Okay, thank you.
Clear,
Aida.
madam.
Okay, good. So now, this is a common question. Dia akan tanya design, how you tackle, or dia bagi ID, VDQ. It will say, confirm your assumption, or it say MOSFET is in saturation. So you need to always go back to confirm saturation. Okay. So let's move to the second question. Ni ke? Ni. Boleh lah ni. Okay.
Madam,
Ada soalan. Saya suka kalau ada soalan. Lama tak dengar orang tanya soalan. Yes, Izzatul.
kalau untuk soalan ni kan dia dah mention dia dekat saturation region. Kita kena
Yes.
assume confirm juga ke?
Yes. Because kita nak, walaupun dia dah cakap memang saturation, but because you need to use this equation, Izzatul. Awak kena guna ID ni. Kita akan assume dulu. Assume saturation, and then ini bila dah betul-betul confirm barulah kita boleh cakap dia betul-betul saturation. Although dia kata MOSFET is already in saturation, but I always suggest my student to write this word, assume confirm. Assume confirm. Although dia dah cakap dia memang saturation. Because suddenly kadang-kadang it already mention saturation, but when you calculate you cannot get the saturation region. So that's bring something else lah. But always make it this as a practice. Although kalau soalan tu nak suruh confirm ke tak confirm ke, I always recommend awak buat macam ni. Okay, Zata?
Okay. Thank you, madam.
Agree tak? Ke tak agree? Dia dah cakap confirm, buat apa nak assume But in the, how I say, in the solution, it didn't show this one. It just say dia ada saturation, but when I say, but I believe that when you use this equation, because you don't know yet, walaupun soalan dah cakap saturation, you don't know yet whether it is saturation. Means ni macam double confirm lah. Yang betul-betul benda tu dah confirm dia saturation. Okay, just make it berarti dia it will not be wrong lah if you just double check. Okay, Zati?
Okay, madam.
Okay. Thank you for the question. Lama saya tak dengar ada orang tanya soalan. Okay, so question number 2. Sketch the current voltage characteristic. So what is the Y, what is the X? Y apa? I apa? Current voltage characteristic. IV characteristic.
ID.
IV, correct. V what? VGS ke VDS?
DS.
VDS. The shape is like this. If you go to Bjt, can you recall back your Bjt? This is I what?
IC.
IC. This is V what? VCE. The shape is the same, right? Okay. Now which one is current control? Which one is voltage control? MOSFET is a voltage control or current control?
Voltage control.
Yeah, yes. So since it is a voltage control, this is V what, Aisha? V what? And this is current control, this is I what?
Yes.
VGS, this is
P.
IB. Okay. What is the role of VGS? Anybody can recall? What is the role of VGS? VGS ni kat mana? Dekat tengah tu. This is VGS. What is the role of VGS? Dia nak provide apa kat tengah ni? Ini, the role of VGS to provide what? What we call in the middle here?
Channel.
Yes, to provide the channel, right? Without the channel, can the current flow? Without the channel, can the current flow?
No.
No. Okay. We need the channel for the current to flow. So different VGS will have different current. The higher the VGS, the bigger the channel. That's why it become higher. And easier, the more current will flow. Same with here. The higher the base current, the bigger the IC. Okay. Now it say here and label the operation mode. So now you need to label the operation mode. Below is always cut off. Now in this part, saturation or triode? This part, saturation. Okay. How about BJT?
Active.
This part, active. So it's opposite. Okay. And here will be opposite. Here is triode. This one will be saturation. Okay. So it will be 4 marks. Okay, now question number B. So this is just a matter for you to plug in the formula. Okay, for your information, your exam is open book. So you don't need to remember any formula. You just need to know how to apply in the limited time. Okay, so now let me explain what is the formula here. ID equal Kn VGS minus VTN. What is the role of VGS? To provide the channel. VTN is the minimum voltage to turn on your MOSFET. Now let's see the Kn. Kn here is what we call what? Ada apa nota tulis apa? Kn?
Conduction parameter.
Yes, conduction parameter. So now, but there is some relation this Kn. Kn is equal to, ada lagi satu formula, K prime N divide by 2 W over L. Is it in the notes? Pernah nampak tak formula ni? Ada tak kat video? Saya tak ingat lah ada kat video. Ada kan? Ada, okay. Now, K prime N here is not conduction parameter. We call this one process conduction parameter. Now, what is W over L here? W over L apa W over L? We have a MOSFET. MOS. Okay. What is the important part here is your channel. The bigger the channel, the higher the current. So the length of the channel here play role. So this is the L. Length of the channel. Now, what is W? W is, dekat MOS ni ada the width of the oxide. So this is what will play role. W over L. So if you Google later after this class, we have in your chip, dekat komputer awak ada chip kan, Intel chip iCore ke what is the latest one, I'm also not aware. So the technology what we call CMOS, complementary metal oxide. So I just give you a brief explanation. So C means complementary, dia ada dua, dia ada NMOS, dia ada PMOS. Means in the same chip you have dua-dua, you have NMOS and you have PMOS. So the one that I previously I work at Intel, I think 10 years ago, right? So I make the layout for this CMOS technology. So if you heard about that time the technology is 0.35 micro technology, CMOS technology. The technology, they make it a chip called Nahalem. Nahalem is the place in US. So usually they make the chip name in place in the US because the production is in US, right? So if you see a long time ago, they have a small computer. Intel produced a small computer, and they use this technology. I think 0.35 or 0.13. I'm not really remember. So what does that mean by CMOS technology? Means this number means W over L. The smaller this number, in one small area, chip is very small, right? Means that maybe 1 times 1 mm. The smaller this number, more resistor will put it inside. That's why you learn about this NMOS. NMOS and BJT, which one is smaller? NMOS and BJT, which one is smaller actually?
And more.
Mana lagi kecil? NMOS, right? MOSFET. MOSFET is very small because we have only one current. So in that, due to this small, dia ada sekarang nowadays is already I think nanometer. Last time is 60 nanometer, 30, become much more smaller. Nano is -9, right? Micro is -6. So this is 10 years ago. So means, what does that mean? The W over L, the length of the channel and the width of the oxide is become getting smaller and smaller. So what does that mean? Maybe 10 years ago, the chip here is maybe 10,000 maybe. But nowadays in the same area, it become maybe 100,000 chips. So when we have a lot of chips, and the processor will be much more faster, right? And that's where you can have a very fast device nowadays with the wireless. Okay, so the cause of this one is what we call inside your formula, W over L. W over L. So this W over L is important. So last time when I work there, what I need to do is I need to draw the layout of this W over all the NMOS. So they have, it's like macam what you see here is a circuit. After the circuit, they will change it to a layout. Means that they have here, we call this one oxide, right? So and this one metal. So in the real transistor, metal is not only one layer. They have like 6 or 7 layers. So the layout here become more much more complicated lah, much more complicated. So if we go here, K prime N. What is K prime N then? K prime N is mu N COX. What is mu N? Mu N is the mobility of the electron, how fast the electron move. COX is the capacitance. This is a parallel plate. Parallel plate means we have a capacitor. So it's a capacitor of what? Capacitor of the oxide, because here you have the oxide. Okay. Then from this COX, you have another formula we call EOX divided by TOX. EOX is here is the, I think the dielectric, and the TOX is this thickness. Thickness of this oxide also play role. So all of this will give the contribution to the current. So that's why I say this area is really matters, the gate area, because this is connected to your VGS kan. So this gate area, either the thickness, the width and the length all play role for you to get the correct ID. Okay, so now let's go to this formula. Consider now the L given here is 1.25, the L below. Mu N is the mobility of the electron, COX is the capacitance, and your VTN is 0.65. So how you can get your W? So it's just a matter of plug in the formula. So as long as you understand the formula, you no need to remember the formula. Formula is given. Okay. So now the question give ID is for KN. Is KN given? No. VGS, how much is the VGS? VGS how much, class?
5.
5, okay. VTN 0.65. So, can you calculate KN first? Remember this one is milli. Current will always be milli inside your MOSFET. It cannot be 4 ampere because this is a very small device. BJT ke MOSFET current will be in milli. So when you put the here, you need to have a milli. So what can you calculate? What is the value of KN? Conduction parameter. Dah dapat bagi tahu KN. Anybody get the answer? KN. Amar berapa Amar?
Sekejap Million tengah kira.
Okay.
0.211.
0.2113.
3.
Okay. Milliampere over V squared. So this is conduction parameter. Tapi soalan tak nak conduction parameter. The question want you to calculate the width of the oxide. So now you need to use another formula. Kn equal K prime N mu N COX. So here 0.2113 milli. K prime N. Is K prime N given? Sorry. I put it wrong. K prime N over 2 omega over L. Okay, let me repeat back. The formula is Kn equal K prime N over 2 omega over L. So what you need to calculate now is the value of the W, right? So Kn just now you get 0.2113 milli. What is K prime N? Given here K prime is mu N COX. So mu N is the mobility of the electron times COX is the capacitance. 10 minus 8. Don't forget to divide by 2. You don't know your W, but you know your L, 1.25 micro. So you just use your calculator and then you can get your W. Okay, so you can calculate later. The answer is around 11.78 micro. So W over L, all will be micro. So this dimension will be micro, the length will be micro. So the smaller the W over L, the higher the number of transistor can be placed in the chip and the chip become more faster. You can have the reading about this one, CMOS, for your extra information. Okay. So is it clear, class? Question B. This one is just a matter of applying the formula. Any question? Ada soalan? Tak ada.
Not yet, madam.
Not yet. Okay. So let's move to another question. Question 3 ni chapter belum belajar lagi. Okay, now we go to question number 4. What is the time now? 4:25. Okay. What is the difference between Bjt and Mosfet? Osman? What is the difference between Bjt and Mosfet? No response. Helmi? Anybody would like to answer?
Bjt current control. Mosfet
Current
voltage
control, voltage control. Another difference? Other than current control, voltage control? Azim?
BJT 3 different current. MOSFET only
3
one.
different current.
Only one current.
Yes, mostly only one current. So in terms of performance, which one is better? Which one is low power?
MOSFET
MOSFET. Why MOSFET low power?
because very small device maybe.
Yes, because it's when the smaller the device, the lower the power it will consume, right? So that's why if you see the your chip nowadays or the technology that we use is not BJT. The technology that we use is the MOSFET. Until now. When we learn here, the gate is only one, right? But if you read the latest one, they call tri-gate. This is much more advanced. Okay, so they use the MOSFET because it is much more smaller and low power. Okay, now let's move to this question. Okay, This question. If you see this question again, you see this word. Confirm any assumption you make during analysis. So always use the word assume and then you confirm. Okay, what will happen to the capacitor? Now you're going to start with DC or AC analysis. You're having how many source here? VDD is a DC or AC source?
DC.
DC. How about VI?
AC.
AC ke DC? AC. Now you have multiple sources, right? So now the first step. Do you need to do DC analysis or AC analysis? What you need to find here? Again, the question say design. You need to find what? You need to find R1 and R2 and also RD. All the R, all the unknown R. So you are given the Q point, ID and VDS. So you need to start with DC or AC analysis. DC ke AC?
DC.
AC. AC tak belajar lagi kan? Okay, DC. Now you see there is a capacitor in this circuit, there is an AC. What should you do with these two if you focus on DC? DC capacitor will be open or short?
Open.
And open. Okay. Hold to that concept. The same concept with BJT. Like I said, if you understand BJT, this one is much more easy to understand. Okay. Open means this one already gone. So and then you leave what we call this circuit. This circuit is called
DC equivalent.
voltage. DC equivalent, correct. And we call this one voltage divider biasing. Why you need to do biasing? Because you want to find the Q point and then to make it active region to make sure it is an amplifier. The same story, right? Okay, now the first step, what you need to do with this circuit? Number 1. Are you going to start to do the loop or you need to change the circuit?
Thevenin.
Thevenin, okay. Okay, Thevenin, tak boleh lari dari Thevenin. So here become RTH. Then do you have RS? No. And then you have your RD and then VDD. Okay, next step. GS loop. Can I have one volunteer? GS loop. What is the equation for GS loop? Naim. GS loop. Naim tak nak jawab. Siapa nak jawab?
Ifah.
GS loop. Ifah. Okay, Ifah. GS loop, Ifah.
Negative VTH
Negative VTH
plus
plus.
RTH IG.
Okay. RTH IG. But do we have any gate current?
No, 0.
No. So directly you don't need to put here. But it's okay if you want to put. But later you take note. We only have one current, right? So when only one current. So kat sini tak ada current flow. Because kenapa tak ada current? Because kat sini ada apa? Ada oxide. Okay. Lepas tu Ifah?
VGS.
VGS equal to 0. Okay. So when you don't have any RS, ni tak ada RS ni, dia directly ground. Your VGS will always equal to your VTH. So this will be simplifying your equation. But suddenly if you have RS here, your equation will become quadratic like in the video. Okay. Okay, now how you can calculate your VTH? What is the formula for VTH?
R2.
What is the formula for R2 or R1?
R2 over R1 plus R2.
Okay.
R1.
Macamnya.
R1.
R1 ke R2? Kenapa R1?
Sebab
Kenapa R1 Ifah? Sebab
voltage divider.
voltage divider. It always take the below one. Doesn't matter ni R1 ke R2 ke R3. So please be careful here. Selalu soalan R1 R2 kan. But here the question change. R2 up, R1 down. So always the upper one become R1. R1 plus R2 multiply by 6. RTH is equal R1 R2 divided by R1 plus R2. Why you need this both equation? Because you have here R1 plus R2 equals 680. So you need to equate here somewhere. Means here become 680K multiplied by 6. Here become R1 R2 divided by 680K. Okay? Because this is a design question. You need to manipulate from there. Okay. Now, BGS done. DS loop. How you need to do DS loop? Any volunteer DS loop? Oh, dah sejam dah. Ada volunteer? Aisyah boleh Aisyah?
Boleh, madam.
Okay. DS loop Aisyah. Starting from -6 plus.
RDID,
Okay, correct. Plus
PDS equals to 0.
VDS equal to 0. Then? Okay. So then you can get here VDS equal 6 minus RDID. But you know your VDS 3.5. But do you know your RD? Is RD given? Yes or no?
No.
Yes.
No. Yes or no? No, right? RD is not given. And you also don't know your ID. So what you need to do next? You can't solve it yet. What is missing is what is the next step? The most important one.
Saturation.
Yes, the assume saturation or assume triad?
Saturation.
Assume saturation. So ID equal Kn VGS minus VTN squared. So you are given your ID. Oh, your ID is already given. Just now 0.75, right? Can you calculate RD here? Boleh kan? Am I correct? Can you? Betul tak? RD boleh kira kan? Am I correct?
Boleh, madam. Boleh.
Boleh eh. So what is the value for RD? Ini soalan nombor berapa ni? 4. Mana solution? Oh, I don't have the solution. So can you calculate the value for RD? So this you can calculate the value of RD, but you don't know your VGS. You need to find your VGS from here. So here 0.75 milli. Kn, what is the value for Kn? 0.03 milli. You don't know your VGS minus Btn squared. Can somebody also calculate the value of VGS? And RD. I don't have the solution here. Nanti question number 3. Berapa RD? Siapa dah kira?
RD 3.33 kilo ohm.
33 kilo ohm. VGS? Dah kira tak? Tak jawapan 5.8 volt eh?
Yep.
Okay. Okay. Next, what you need to do? You only know RD but you don't know R1 and R2. You are going to put this VGS here, means your VGS is actually your VTH, right? So from this equation, you just plug in. So 5.8 equal R1 divided by 680K multiplied by 6, then you can get your R1. And then how you can get your R2, just put here. Okay, so I believe from here you can solve it. But are we done now? Is it a complete solution?
Confirm.
Confirm, yes. Don't forget the word confirm. So now let's try to confirm. VDS set, what is the value of VDS set? 5.8 minus 0.8. So it become 5. Your VDS here is how much? 3.5. Am I correct? Now, is it less or greater? What is the condition now? Is it in saturation or in triad?
In triad.
Triad.
Yes, because it is less, right? It is less. So, can you stop? Is the value that you get here is correct? Is it done? Because just now you assume saturation, but when you confirm, it is not saturation. It is triad. Do you need to proceed to triad or you are done now? What do you think, Azim?
Proceed to triad.
Yes, you need to proceed to triad. Proceed. It's not done yet. So, later you do by your own. Nanti awak kena pakai balik equation ID equal KN yang panjang. Then you need to plug in back the equation. Sometimes in the final, if you see like this, oh no, what happened actually? But sometimes it's actually the question intend you to change to triad. So this what happened inside the MOSFET equation. Usually what we did, we always try our best for the question setter to make it in saturation. But I'm not sure what happened to this question. Maybe this question intend for you to make it in triad. So you need to do again the triad along equation until you can get the new R1, R2 and R2. Okay? Okay, so don't stop until here. Yeah. Yes,
Nak
Hani?
tanya,
Boleh?
kalau macam soalan ni kan, contoh kalau kita cari VGS tu, kita terus confirmkan dia in saturation or triad, kan kita dah tahu yang dia bukan in saturation. So perlu tak kita cari R1 yang R2 tu untuk yang saturation tu?
This will atasnya still dapat markah lagi. Means atasnya awak assume saturation kan, then awak dah kira lah ni R1, R2, dan awak nak settle down lah ni, just nak confirm je dan tapi bila when you confirm suddenly alamak yang ni dia tak saturation lah, dia triad. And you cannot stop there. Awak kena yang atas ni jangan padam. It still count marks. Means that you still proceed atas ni, okay, tapi this is not the final answer. R1 and R2 that you got just now is not in the saturation mode. Means this is not the real R1, R2 lah. So you need to continue until you get the new R1 and R2. Tapi awak jangan padam lah apa yang kat atas ni. The one that you go through up here is already correct. Just maybe there is two possibilities. One, maybe the question is the question setter doesn't intend to make it in triad, suddenly it's in triad. And maybe the question setter want in triad, they want you to use this triad. So there are two possibilities here. But from my experience, usually the question will always in saturation. Not ke triad is a very long equation unless memang question setter tu nak buat lah dalam triad. So ni macam you still this all above ni this still count marks, bukan awak dah nampak triad awak kena padam balik atas ni, jangan padam. It still all this become a steps until you recalculate lah. So kalau kat sini memang akan stuck lah, maybe nanti sebab dia ada square kan, it's become quite complicated here, but as long as you show up there, yeah, it will be almost dah full mark lah. But don't forget to confirm. That's why I say the confirmation is important for MOSFET. Okay, Hani?
Okay.
Am I answering your question? Okay. So this is seldomly happen, but unfortunately this question happened. So you need to confirm in triad. Okay, last question before we finish. This is the fresh question from last semester. Suddenly we have I really want you to show you this question because this is a bit out of the box question. You have a diode here. So although diode is not covered inside the final, but this is an integration of the diode and the MOSFET. So if you see this question, show a NMOS switching circuit to switch. When I say switch, just now your NMOS, you have two functions, right? One is as an amplifier, another one as a switch. If you want to make it as an amplifier, okay, We need to bias in which region? Saturation, triode or cutoff? I want to make NMOS as an amplifier. Which region that you need to bias?
Saturation.
Saturation. Okay. But if you look at this question, show NMOS MOSFET switching circuit to turn on and turn off. Turn on and off means switch. Means on, off, on, off, on, off. So what do you think happened here? When you do biasing, do you need to bias in triode or saturation?
Triad.
Triode. Okay. So please question ni dia lain sikit. Usually question akan keluar voltage divider macam ni. Tapi suddenly here you have a diode. So you need to be careful here. So when I say switching, biasing in triode, so here in the solution here, you are going to expect to use triode equation. Triode equation. Okay. So let's see the question. Btn and lambda is equal to 0. What does mean by this lambda? What is lambda? Okay, let's go back to the IV. In ideal condition, your graph will be, the current will become constant, right? Let's say this is IC, the one BJT. But in your real condition, it will not be constant, dia macam ada slope sikit. So when there is a slope, it will go to one point. Apa kita panggil point ni? Ingat lagi tak yang chapter yang lepas? Kita panggil apa ni? Early voltage. Kan? Agree tak? Ingat lagi tak? Apa benda? VA, right? When there is a VA means what? You have R0 kan? Yang dekat dalam chapter berapa tu? Amplifier tu kan? R0 equal 1 over VA. Ke apa? VA over ICQ kan? Satu macam tu lah. So you have VA. Same happen here. Ni BJT. But now what happened to the MOSFET? MOSFET in ideal dia macam ni, tapi in the real condition dia will have a slope. Then the slope will meet to one point. Again, you have VA. What we call VA, early voltage. But in your MOSFET, VA will be equal to 1 over lambda. That's where you have a lambda here. Okay, so this one, you need to use this one later for amplifier. For now, you can just ignore this one first. Okay, now let's go back to this question. V gamma LED is equal to 0.2 volt. So what does that mean? V gamma. What is V gamma? MOSFET ada V gamma. V gamma tu apa? Ingat lagi tak? Ni V gamma. What is V gamma?
Turn on voltage.
Yes, turn on voltage. Correct. Turn on voltage. So the minimum voltage to turn on the LED is 2.2. So the V gamma here is 2.2 volt. Okay. So don't panic when you see lah ada diode pula kata minum tak keluar. So don't panic. Ni ada V gamma je. So means what does that mean? This is model 1. You just need to change your V gamma to a constant voltage called V gamma. So if I redraw this one, ni RD. So ignore je the diode tu, dia become V gamma 2.2 volt and then you ada MOSFET. And then this become a normal circuit. Okay. And the question say design the circuit by find RD such as the ID 11.5, Vin is given 6.2, VDS is also given. VDS means V out. So V out here, VDS, right? 0.184. Okay. First of all, when you get this question, don't panic. Always look at, go to the same equation. First you have GS loop. Another one you have DS loop. So now let's move to the GS loop. What is the value of VGS? Anybody who want to try? What is the equation for GS loop? GS loop. Kat sini. Dia tak ada resistor, tak ada apa-apa ni. Tapi dia ada V in, dia ada ground. In between here, you have VGS. So what is the equation? Anybody would
VGS
like to try?
equals VN.
Okay, Farizi. VGS equal to VIN.
VN.
How you can get? Yes, correct. If you can't see it, you just complete the loop. So you start here minus VIN plus VGS equal to 0. So you can get the same. Okay. So means your VGS here is already a value. That is how much? 6.2 volt. So you already know your VGS. So now this one is settled. Now let's move to the DS loop. So can I have one volunteer to have DS loop from here until here? Who want to try? Last question for today.
Me, madam.
Honey. Okay, honey. Minus.
Minus 5
Okay. Plus.
plus RDID
RDID plus
plus 2.2
2.2 plus
plus 0.18
VDS, right? 0.18 then
equal to 0.
equal to 0. Correct. Okay. So just slowly go through the DS loop. Okay. Now let's see. ID is given. Yes. 11.6, right? So you can get, let me check the solution. Yes. So you can you calculate your RD is equal 5 minus 2.2 minus 0.18 divided by 11.6. Can you get the same answer like below? Anybody can calculate?
Yes.
Yes. Okay. Okay. Now you didn't finish yet. There's also the question say design, right? Design the circuit by determining, say this one done. Next, you need to find what? You need to find W over L, the technology just now, the width and the length of the oxide. So now, you are going to assume in saturation or in triode. This is a switch circuit. You are going to assume, because W over L is in which equation? Is the ID equation. So now you're going to use which equation of ID? Triode ke saturation?
Triad.
Triode. Kenapa triode? Is that it? Why triode?
Sebab soalan mention to switch.
Yes, soalan mention to switch because when it is switch, you need to bias in triode. Okay, now let's try together. What is the equation for triode? Boleh buka buku balik. ID equal to apa?
Okay.
Anybody can help me? KN 2 VGS minus VTN.
VDS
Next,
minus VDS square.
VDS squared. So it's a bit lengthy equation. Okay. Oh, okay. Now you know that you need to find W over L. In order for you to find W over L, you need to find Kn first. So don't plug in here yet because this is already complicated. So remain the Kn there. Later you find W over L. So it become here 11.6 milli. Don't forget the milli. Okay. Kn do. Now let's replace the value. VGS is how much? 6.2, right? Am I correct?
Yes.
Are you with me? Yes, right? So BTS 55. VDS is given 0.18 minus 0.18 squared. Okay, can you calculate? I'll wait for you to calculate. Okay, I make slide a bit bigger. Okay, what is the value of Kn? Okay, I'm missing something now. I'm using this equation. Can I directly use this equation or I miss one sentence before? What should I write here?
Assume.
Yes. Assume. Saya pun tertinggal. So always say assume. Assume what? Assume triode or assume saturation?
Triad.
Assume triad. Don't forget to write this equation. Okay, so what is the value of Kn? Siapa dah kira? $4.50. Sikit lagi, last.
5.78 mili.
5 point, I dah baca. 5 point, yes, correct. 78 milliampere over V squared. Okay, now Kn equal what? K prime n over 2 omega over L. Because what you need to find this question is omega over L, right? So you get 5.78 milli equal K prime is the conduction process conduction parameter. So here given 0.007 milli divided by 2 omega over L. And then you can get your omega over L. Then this one later you calculate. You can get here around 166 omega, not omega, W over L. Okay. Is it done now or am I missing something? Dah siap ke belum ni?
Confirm, madam.
Yes. Don't forget to always confirm. So let's try to confirm. VDS saturation. What is the value of VDS saturation? VGS minus VTN. That is 6.2 minus 0.55. Can you calculate how much?
5.65.
5.65. So this is VDS saturation. Your VDS is 0.18. So now it is greater or less?
Nice.
Less. So is it confirmed triad?
Yes.
Is it confirmed triad? Yes. So you need to write here confirm triad. Confirm triad. Okay. Let's say you forgot. You don't know whether I'm going to start with saturation or triad. You still can start with saturation, but when you check the assumption, it is wrong. So then you need to restart back with triad. So for the shortcut way, when you see the question is switching, directly go to the triad equation. Okay? And then you just use your W over. Ada soalan tak? Jangan ada orang nak tanya. Najmi nak tanya apa-apa? Yes, Najmi? Najmi? Anything you like to ask? No? Yeah, okay, okay. So, yes, Izatul?
Untuk W over L tak ada unit lah kan?
Tak ada, sebab W tu apa? Again, I redraw Dia tak ada unit. Metal oxide semiconductor, right? So this is N. Where is the L? L is the length of the channel in micrometer. What is the oxide? This is the width of the oxide, micrometer. So there will be no unit. Micro will be cancelled out. So it's a ratio. The smaller the ratio, the smaller the NMOS, the higher the number of transistor can be put in one chip. So this play the role of, if you just write later, this is actually a good information for you. So you just write CMOS technology, the technology will always rely to W over L. So when we draw if you go to the top view, yang ni dia punya oxide, right? So when it says CMOS, here is NMOS, here is PMOS. Yang length ni yang play role. The length, the width and the length of the channel, the oxide ni. So dia tak ada unit. Okay, is that it?
Okay, madam.
Okay. So no unit. Okay, I think I have a bunch of this one combination. Yang ni pun ada soalan lagi, so you can try. I have post this inside the Google Classroom and also Telegram, so you can try by your own to answer the rest of the question. Leave the chapter 6 yang amplifier, abaikan dulu So this is also a good example, another example that you can try. Draw the load line. So as long as you understand the load line of the BJT, the concept will be almost the same for the NMOS load line. Okay, so the understanding is parallel. From chapter 1 that you learn from electronics, the theory will help you to assist to solve the equation. Okay, so I will share with you this yang sudah conteng ni in the Google Classroom later. So with that, we conclude chapter DC. Quiz next week kan. So I will release the last chapter. So we have last chapter, question number 4, MOSFET amplifier. So you will learn about common source and common drain. So this week will be common source. So I think I already put inside the Telegram and the Google Classroom. So there is 4 videos, each around 7 minutes. So take your time until this Wednesday. Whatever that you can finish, then we can discuss some of the question for common source. Is it okay, class?
Okay,
Sebab
madam.
minggu depan dah last ni kan. So my advice, try your best to understand BJT amplifier first. Because if you can't understand BJT amplifier, yang ni dia susah sikit nak follow. But if you really understand BJT amplifier, yang ni macam much more a bit easier than the BJT amplifier. So if you still have something to ask about the BJT amplifier, please let me know earlier before the next class, okay? So with that, we almost 5. Can I have one brothers to recite doa before we finish our class for this 1st June? Helmi boleh Helmi? Okay.
Bismillahirrahmanirrahim. Alhamdulillahirrabbilalamin. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Ya Allah, ya Tuhan kami, Kau ampunkanlah dosa-dosa kami, Kau ampunkanlah dosa kedua ibu bapa kami, Kau ampunkanlah dosa guru-guru kami. Ya Allah, ya Tuhan kami, Ya Allah, ya Tuhan kami, Kau berikanlah kesihatan yang baik ketika kami menuntut ilmu dan Kau berkatilah ilmu yang telah kami pelajari. Ya Allah, ya Tuhan kami, tunjukkanlah kepada kami kebenaran agar kami dapat mengikutinya dan tunjukkanlah kepada kami keburukan agar kami dapat menjauhinya. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Wa sallallahu ala sayyidina Muhammad wa ala alihi washabihi wa baraka wasallam. Walhamdulillahirabbil alamin.
Amin, amin ya rabbal alamin. Thank you Helmi for the beautiful doa. So with that, for those who are at Mahalah, again, tomorrow will be lockdown, right? So if you need any help, please let me know. And for those who I message personal, can you stay after this class? And if you have any question for you to ask, let me know also earlier. Okay, with that, we end our class with Tasbih Kifara and Surah As.